Heyo, I hope you had a nice long weekend. Friday off as well. It's been nice weather as well, so apart from yesterday. No, it was also good. Anyway, losing track of my days. You don't even know when yesterday is because you don't know when I'm recording this. Um, so hopefully you remember your triangles, and we're going to get on to what I think is more of the actual applicable part of this density and compound measure topic, and the little bit harder version that I've kind of hinted to in previous lessons. So the way this is going to go is I'm going to do two examples myself, and then I'm going to put two examples for you to have a look at and answer yourself. I'll give you a clue if you need it to. Pause the video if you don't. Then I'm going to show the answers. If you've got them right, click off the video, go answer the couple of questions I've put on a PDF for you. If not, hang around after you've checked them answers and I'm going to go through them too as well. So on this video I'm going to do 4 questions for you. 2 of them you should do yourself. This is where we've got 2 parts of a journey or 2 objects and we have to combine them. This is kind of a new method to me that I've only started doing recently this year, and it's just made them so much easier. So we need to be doing this kind of 2-way table method whenever we see a question like this where we've got 2 parts of a journey or 2 objects. Sometimes you might want an overall column at the end. We'll see that in a second. And you all know how 2-way tables work. This is the speed, distance and time for the journey Fullbeck to Ganby, and then Ganby to Horton. So let's just read through the question. I've filled out a bit of the table for us, but I'll show you how I would have filled it out. So first of all, I know it's a speed, distance, time question because I've got distance, I've got speed, I've got time. I just know it's going to be one of them. So I'm going to put the parts of my journey. Fullbeck to Ganby here, and then Ganby to Horton. They're my 2 parts of the journey. And then I'm going to write speed, distance, time. Because speed equals distance over time, they're the 3 things we've got in this triangle when we put it together. And I'm just going to read the information and fill in my table as I go along. So the distance from Fullbeck to Ganby is 10 miles, so that's why I've put 10 miles here. The distance from Ganby to Horton is 18. So that's why I've put that there. They're going to drive, blah blah blah, leaves at 10 AM. She drives back with an average speed, so she drives from F to G with an average speed of 40. That's why I've put that there in the F to G line. She wants to get there by 10:35. That's not going to be something we're going to do any calculations with. Once we get our answer, we're going to check if she's done it in less than 35 minutes to get from 10 to 10:35. But can you see from this table that we're just, all this is doing is just organising our information. So straight away I can think, well, I can find the time here because I've got speed and distance. We know that speed equals distance over time, so the speed is going to be, the distance is 10 miles and the time is 40. So that's going to be 0.25 hours. Our answer is going to be coming back in hours because we've got miles per hour. And 0.25 hours, well, that is 15 minutes. So if I click that, quarter of an hour, 15 minutes. Well, we're going to use this to find some other information. So if she wants to get to Horton by 10:35, that is 35 minutes. So we know this time must be, take a guess, what must it be? It must be 20 minutes because we've already driven for 15. So the longest she can spend on this part of the journey if she wants to get there on time is 20 minutes. And 20 minutes as out of an hour, 20 over 60, that would be 0.33 recurring, or a third of an hour. So we put that there. And then we can see, well, we've got 2 things in our line for G to H. We can then find the speed. I'm going to do that just over here. I've marked it with a little star. So speed, distance, time triangle. We're trying to find the speed, so cover that up. So we're going to do distance over time. So speed equals distance over time. I have a feeling I got lucky on this, and I did it wrong. Or did I? Speed equals distance over time. Oh yeah, I would have done it. This should have been time equals distance over speed. It would have been the exact same numbers. I just wrote it down wrong in my head for some reason. Sorry about that. So distance over time. Distance is 18. Time is a third, or 0.33. Get your calculator out, or maybe you know that that would be 54. So she must travel 54 miles per hour to get to her destination within 35 minutes. If she travelled faster, she'd get there sooner. So the minimum she'd want to travel in that second part of the journey is 54 miles per hour. Okay. We've got another... oh no, we've got... Yeah, it works with density as well, so I'm going to do a density question here. So this might be a bit more in your head, because this is kind of the stuff we did on Thursday. Again, I'm going to show you where my information's come from. I've got liquid A, liquid B, and then combined, which is C. So we put C, A and B together to get C. Liquid A has a density of 1.42. I've put that here. So I'll cross that off once I've used it. 7 centimeters cubed of liquid A. That is a volume, isn't it? Centimeters cubed. So that's why I've got the 7 here in my volume column for A. It's mixed with 125 centimeters cubed of B. So that's why I've put that 125 there. Well, straight away, we know what the mass, the volume of C is. If we put 7 centimeters cubed and 125 centimeters cubed of something in the same cup, it will combine to be 7 plus 125, or 132 centimeters cubed. So we've got the volume for C. C has a density of 1.05, so I'm going to put that up here in my C column. That's all the information from the question. Look for some stuff that we've got 2 of, and look in your columns first before your rows. So we can find the mass of this. Density equals to mass over volume. We want to find the mass, so we're going to do mass equals to density times volume. So 1.42 times 7. That is going to get me 9.94. Yep. And just having a quick check of what your units would actually be. This would be in grams, because our density is measured in grams here. Grams per centimetres cubed. You don't need to write your units in these tables, but always make sure you're using the correct units, because you can get tripped up otherwise. Okay, and then through the same method we can find this. So mass equals to density times volume, 1.05 times 132. And that gets me 138.6. So again, that's grams. Something we can do with the mass and the volume that we can't do with the density is work along our rows, because we know if we add 2 things with a certain volume, the volumes will just combine with an addition, and similarly for mass, because they aren't compound units, they're just simple units. There's just one thing in there, centimeters cubed or grams. So to find this, well, I can just do, if 138.6 is the total and 9.94 is what A is, well, liquid A, the mass of liquid A plus the mass of liquid B would give us C, so I could do the opposite of that and do a takeaway. And that's going to get me 128.66. We can't just do that on the density, because they're a compound unit, it's grams per centimeters cubed. So just putting two things together doesn't add the densities together, because they're a bit more of a complex unit of measurement. We have to go about the proper method. So what we've done here is we've worked to get two things in this column. So now with this we can actually, well, density equals to mass over volume. We've found the mass, we've found the volume. We can go ahead and do that division. So if you do 128.66 divided by 125, you're going to get 1.02928. So this is really important for the speed, distance, time and the density, mass, volumes. With mass and volume you can add and subtract across the columns to find your combined. You can't do it with the density. With speed, distance, time, you can do it with distance and time, but you can't do it with speed. You have to go about the full method and find your mass and volume, or your distance and time, and then do your triangle to calculate the density or the speed. So then our final answer is this. Remember your units and remember to follow the 2 decimal places. Okay, 2 questions for you to have a go at. I've left the tables completely blank for you to have a go at if you think you've got it. If you're still a little bit iffy on it, what I'm going to do is I'm going to fill out the information from the question for you, just as a bit of a hint. So you can either pause it now if you don't want me to do that for you, or you can keep watching and then pause it after I've filled in a bit of the table for you. Okay, so Papa Smurf has walked 10 meters at 5 meters per second from A to B. So a distance of 10 and a speed of 5. And then he's walked 5 meters from B to C at a speed of 10. So that would be the information from the question. From there, well, I can say he's walked a total distance of 15 meters. So maybe you can have a go from there. I know you can go ahead and find what these two are, add them together to find this, and then use these two things here to find our final answer. Okay, pause it, and I'm going to go through the solution in a second. And so, go on then, I will do the quick answer to this one. So we would have 6 meters per second as our final answer, so well done if you've got that. Worked solution, I will do it at the end just in case people want to see both of these. So let's just let me do the information filling in for this. So Bob the Builder needs to travel to the building site. He drives the first part of the journey of 10 kilometers at a speed of 20. The total journey, so that's the total time, is 1 hour. I'm just going to put 1 there. What speed did he drive for the remainder if his average speed of the journey was 40? So that means his overall speed of the journey was 40. So that would be all the information from the question. So if you were waiting for that one again, there you go, have a go at that one. I'm going to pop the answers up for this too. So what speed did he travel? We're looking for what this box is here. So if you got the answer as he drove 60 kilometers per hour for that, well done. Go ahead and get yourself onto the questions on the sheet. If you're wanting to stick around for some worked solutions, I'm going to go through both of these now in a bit of detail. So what I'm actually going to do is get all the boxes back up, just so we know what we are needing to find. So we can just figure out the times here, can't we? We've got our triangle, speed, distance, time, and we're wanting to find the time, so cover that up. So time equals to distance over speed. So in this case, A to B, the distance is 10 and the speed is 5. So the time it's taken is 2. In the context, that would be 2 seconds. Think about it, if he's moved at 5 meters per second, it'll take him 2 seconds to go 10 meters. So that seems to make sense. And then B to C, well, we're finding the time again. I'll do them where my arrows are pointing. I've done them for a reason. So time equals distance over speed. So distance is 5, speed is 10. So this one is going to be a half, or we could say 0.5. I don't know why I did that. So then our total is just going to be the 2 times it's taken. If it's taken 2 seconds and then 0.5 seconds, it's obviously taken 2.5 seconds. We can then do our speed equals distance over time. Distance is 15, time is 2.5. So 15 divided by 2.5, that gives me 6. And remember your units. Well, that was a nice random speech bubble it did for me. 6 meters per second. Okay, and then this one. Filled in the information we've got. Let's go ahead and find this. So we've just did up here that time equals distance over speed. So 10 over 20. Okay, this one again is 0.5. I'm not sure why it's doing that random line for me today. It's never had that problem before. So if that's taken 0.5 hours, essentially 30 minutes, and this has taken 1 full hour, 60 minutes, this is also going to take, oh, flipping heck, 0.5 hours, because 30 minutes and 30 minutes makes an hour. We can then find this, so you kind of just fill in a bit of doing a bit of a puzzle here, aren't you? Just anything you've got 2 of in the column, just figure out what it is. So speed equals distance over time. Don't worry, the more you do these, the quicker they get. And they probably take a long time the first time you do them. We want to find the distance, so we're going to do the speed times the time. So that would be 40 times 1. I'm not going to do that for you, that would be 40. I mean, it makes sense as well. If you're going 40 miles an hour, you're going to do 40 miles in 1 hour. If the distance is 10 something to make a distance of 40, that is going to be a distance of 30 miles or kilometers. And then we can find this through, we want to find the speed, we've got the distance, we've got the time. So speed equals distance over time. 30 divided by 0.5. Do that in your calculator, you're going to get 60. Okay. And that's they're your questions that will be on a PDF, but that's everything from me. Alright, thank you.